Chapter 7, Section 5, Process of Statistical Hypothesis Testing, Part 2. In this video, I will explain one-tailed test and a two-tailed test in detail. In the previous video, we saw the process of statistical hypothesis testing. In step 1, we need to specify null and alternative hypothesis. In step 2, we set the significance level. In step 3, we calculate test statistic. And in the final step, we determine whether we can reject a null hypothesis or not. In this step, we need to calculate the p-value from test statistic, and then compare the p-value with the significance level. The final step of hypothesis testing is determining whether we can reject a null hypothesis or not. We can do it by either one-tailed test or two-tailed test. As you know, a null hypothesis expresses the size relationship that contains an equal sign. So, it expresses that A equals B. A is larger than or equal to B, or A is smaller than or equal to B. Therefore, to determine whether we can reject a null hypothesis or not, we need to show either of the three relationships proposed by alternative hypothesis is true. The first one is A does not equal B. That is, A is larger than or smaller than B. The second is A is larger than B. In this case, we do not care whether A is smaller than B. And the third is A is smaller than B. In this case, we do not care whether A is larger than B. A hypothesis test that determines the first is called the two-tailed test. Since it tests whether A is larger than B or not, and whether A is smaller than B, it needs to test both the upper tail and the lower tail. In the second and the third cases, we should use a one-tailed test. It tests whether A is larger than B or not, or whether A is smaller than B. It tests either the upper tail or the lower tail. In the first case, a two-tailed test, we can reject a null hypothesis when A does not equal B. That is, A is larger or smaller than B. But in the second case, a one-tailed test, we can reject a null hypothesis only when A is larger than B. We cannot reject a null hypothesis even if A is smaller than B. In the third case, a one-tailed test, we can reject a null hypothesis only when A is smaller than B. We cannot reject a null hypothesis even if A is larger than B. A two-tailed test is used to examine whether A and B are equal or different. A one-tailed test is used when we already know that one is larger or smaller than another. In most cases, we cannot say that one is larger than another, so a two-tailed test is more commonly used. Suppose we set the significance level at 0.05. In a two-tailed test, the 0.05 is the sum of the upper tail and the lower tail. So, each of both sides is 2.5%. On the other hand, in a one-tail test, the 0.05 is the upper tail or the lower tail. So it is the upper 5% or lower 5%. The painted areas are called rejection region. If the values of the test statistic fall within the area, we should reject a null hypothesis. Let's summarize the points of this chapter. In diagnostic analysis, we reveal causal relationship between variables, often using inference statistics. In inference statistics, we make inference by collecting and analyzing sample data. The law of large numbers and the central limit theorem are important mathematical foundations that endorse making inferences from sample data. The central limit theorem is an elaboration of the law of large numbers. And the notable point of the central limit theorem is that it holds irrespective of whether the population follows a normal distribution or not. This chapter also covers the process of statistical hypothesis testing. Through the process, we test a hypothesis by determining whether we can reject a null hypothesis or not. We can make the decision by comparing the p-value with the pre-specified significance level. A p-value can be calculated from test statistic. A p-value represents the probability that the observed difference occurs when the null hypothesis is true. That is, a small p-value does not mean that the observed difference is large. It means that our observation is a chance of a product. So, even if we get a very small p-value, our observed difference is very small, but it can be observed also in the population.